Hi all. We now look at integrals that require the use of trig substitutions. In this case, we're going to look at the first two, a and b, and here most of these will require the use of x is equals to a sine theta. So these types of substitutions work for situations where you have an integral of 1 over, and then you have a root of some constant number a raised to a power minus x raised to a power, and then you're integrating with respect to x. So here on top, sometimes you might have a variable, again x or x squared, basically a function, another function, but yeah, our interest there is in that square root in the denominator. So if you have something like this, if what you have here is the x squared term is the one with the minus, then you can use this substitution. If instead what you have is 1 over, then this time around you have root of, so if instead what you have is x here squared, and what is minus now is the constant there. In this case, to work out this one, so notice that it's basically the same expression as the one on top, but the difference is now x is positive and a is the one which is negative. In this case, the best that you can use to solve this would be to let x be equals to either a sec theta, or we can approach it by using x is equals to a hyperbolic substitution. So a, and then you have cos theta. So one of these is going to work depending on which one you're comfortable with. Another type that you can also encounter is where you have 1 over, and then now you have a squared plus x squared. So this one can come sometimes without a root, sometimes it can even come with a root. But for this one, where both a and x squared are positive, you can use x is equals to a tan theta. So this can work. So basically that is that you go with this substitution if both a and x are positive. So hope we encounter these as well as we proceed, but in the meantime, let's focus on a and b. So in a we have the integral of x squared over, then we have root of 9 minus x squared dx. So when we look at this one, we see that we have the variable being negative and the constant being positive. The first thing that you want to do is understand which one is a. So notice that a is going to be squared as well. A has to be raised to a power 2. The number that you have here is a 9. It's not raised to a power. That's just power 1. So to figure out what a is, you need to get the square root of 9. The square root of 9 is 3. So this is the same as 3 squared minus x squared. So in this way, we now know that our a is 3. And since the variable x is the one that is negative, we're going to use the sign substitution. So x will let x be equals to a, which is 3 sine theta. If we did this, the derivative of x with respect to theta will be 3 cos theta. And this will imply that dx is equals to 3 cos theta d theta. Now we make the substitution. Our integral now becomes, where we have x, we're putting 3 sine theta, so this becomes 3 sine theta, but in the numerator, x is squared. In the denominator, we now have 3, that's 3 squared. I can bring it back and present it as a 9. We see x squared again, so x squared is due 3 sine theta squared. Then we have dx. So dx, that is 3 cos theta d theta. So now when we simplify this a little bit, in the numerator we now have 9 sine squared theta over, in the denominator we have 9 minus 9 sine squared theta. Then here we have 3 cos theta d theta. We can factor out a 9 in the under the root there and then square root it. The 9 in the numerator can come out to give us this. So that we now have 9 sine squared theta over. When we factor out this 9 and this 9 and then square root that, it becomes a 3, leaving us with a 1 here minus sine squared theta over 3 cos theta d theta. These 3 and these 3 will cancel out, and then we recall that from sine squared plus cos squared is equals to 1. It follows that if you have 1 minus sine squared theta, this would be cos squared theta. So now we have 9 integral of sine squared theta cos theta over the root of cos squared theta. When you square root cos squared, you get just cos. So this cos that will come from here and this cos here will cancel out, leaving us with only the integral of sine squared theta d theta. Now to integrate a sine, I think we have seen this before, where when you have to integrate sine squared, you use the identity sine squared theta is equals to 1 minus cos 2 theta over 2. And if you have to integrate cos squared theta, we use 1 plus cos 2 theta over 2. This time around we have sine squared there, so we're going for this, the integral of, where we have sine squared, we're going to put 1 over 2. I'm just going to present this, but just as two fractions. 1 over 2 minus cos 2 theta over 2 d theta. So when we integrate the first part, we just get theta. When you integrate the second part, we're going to get so we're going to first differentiate the numerator, the argument there giving us a 2, the 2 multiplied down giving us a 4. This one was theta, of course, over 2. So let's differentiate that, giving us a 2. A 2 multiplies down to give us a 4. Then the derivative, the integral, not derivative, then the integral of course will be sine 2 theta, like that. So plus c. So at this point we can distribute the 9, giving us 9 over 2 theta minus 9 over 4 sine 2 theta plus c. Okay, let's go through that one more time. Let me just make sure I haven't made any error. Integrate half d theta, we get half of theta, which is this. Then integrate cos 2 theta over 2. First differentiate the 2 theta to give us 2, divide the 2 down giving us a 4. The integral of cos is sine, so the argument remains the same. It becomes 9 over 4. Okay, that's fine. So at this point we want to go back to the variable that we initially had. So if we check, our variable was x, and we related x to theta here, where we said x is 3 sine theta. So we now want to use that relationship to eliminate theta and go back to x. We said x was 3 sine theta. So here it follows that sine theta is equals to x over 3. So if we want to know just what theta is, theta will be sine inverse of x over 3. So we now know what theta is. But look at this. When we bring it here, where we have theta, of course, we're going to put sine inverse of x over 3. But the problem is, in that second part where we have 9 over 4, where we have sine 2 theta, are we going to say this is sine and then 2 and then sine inverse because we have that theta there? This doesn't look good. This is the loop. Okay, so you now want to find a way of presenting sine 2 theta properly. To understand what sine 2 theta is, we recall the identity to say if we have sine 2 theta, this will be equals to 2 sine theta cos theta. We already know what sine theta is. We know sine theta is just x over 3. Now how about cos theta? Since we already know sine, we can use a right angle triangle. If this is where theta is, since sine theta is equals to x over 3, so the opposite has to be x, hypotenuse has to be 3. In this way, the adjacent by Pythagoras theorem will have to be the hypotenuse squared, which is 3 squared, minus x squared, giving us this. From here, we see that cos theta becomes the adjacent, which is root 9 minus x squared over the hypotenuse, which is 3. So now we know what cos theta is. So where we have cos theta, we'll put root of 9 minus x over 3. So that sine 2 theta now reduces to 2x root 9 minus x squared over 9. So we can now substitute here where we had sine 2 theta. So sine 2 theta was here. So in place of sine 2 theta, we will put 2x root of 9 minus x squared over 9. This 9 and this 9 will cancel. 4 and 2 will cancel once, giving us 9 over 3 sine inverse of x over 3 minus x root 9 minus x squared over 2 plus c. So this becomes the final solution. Okay, so I hope we didn't leave anything. Okay, I think this looks okay. So the next one that we're going to look at is going to be b, and in b we have x plus 1 over root of 4 minus x squared dx. So in this case again, I see that what is squared is, as in what is negative is the variable, and the constant is positive. So because of that, I'll still let x to be equals to a sine theta. My a this time will be the square root of this constant, which is 2, becomes 2 sine theta. If I did this, dx becomes equals to 2 cos theta d theta. Okay, so now we substitute. Where we have x, we are putting 2 sine theta. So this is root of 4 minus, I put x again, square it. So we get 2, we get 4 there. Then sine squared theta. Where I have dx, we're putting 2 cos. Then the same way, we deal with that square root. So the square root, the 4 comes out, gets squared, becomes a 2, leaving us with 1 minus sine squared theta. The 2 and the 2 cancels. We know 1 minus sine is 2 cos squared. So now I have 2 sine theta cos theta over root of cos squared theta. Root of cos squared is just cos. So the cos that will come from here and that cos will cancel out, leaving us with 2 sine theta plus 1. So this is the integral that we now have to evaluate. So now this can actually be evaluated. 2 sine theta d theta plus d theta. The first part, integral of sine, is negative cos, then the integral of d theta will just be theta. Then again, what is theta? So recall where we defined theta, we said theta, x is 2 sine theta. So from here, we see that sine theta is equals to x over 2, so that theta is sine inverse of x over 2. So we now know what theta is, but we need cos theta. So to get cos theta, again, we go back to the triangle. If this is theta, sine theta is x over 2, so it will be x over 2, implying that this side here, the adjacent here, has to be the hypotenuse, which is 4, as in 2 squared, minus the other side, which is x squared. So that now cos theta will be the adjacent, which is root of 4 minus x squared, over the hypotenuse, which is 2. So now our overall solution becomes minus 2, where we have cos theta. We're putting root of 4 minus x squared over 2 plus theta, and theta is sine inverse of x over 2, then plus c. So I can simplify this so that now we have minus root of 4 plus sine inverse of x over 2 plus c. So that becomes our final solution. So end here for this video. The next ones that we're going to look at will be these, and these will require us to first complete the square before we can get the roadmap on what we have to do next. So you can try them out, C and D. First complete the square, then try to work them out. But we'll look at them in the next video. All right, all the best.